Hey, calculus class. This is the last section for your derivatives. We're talking about exponential and logarithmic functions. Um, so pretty much this is the last set of derivatives that you are going to learn for this class. And then the next chapter, we actually start applying them to real life situations and all that good stuff. So yeah. So here we're talking about again the derivatives of exponential functions, logarithmic functions, and logarithmic differentiation. We'll talk about that again also. We already talked about this implicit differentiation, so in 3.7. So that's kind of like similar to what's going on here, but we're going to talk about that. All right, so example one says, looking at these graphs here, these pairs of graphs, which one can actually be a graph of the original function and the graph of the derivative? Now, one thing we know about when it comes to our derivatives, that if the original function is a certain degree, for example, like x cubed, that means when you take the derivative, it goes down 1 degree, which means it's x squared. So if you take a look at, for example, 2 here, this is a parabola, which means this is a quadratic function. So it's going to be f of x equals negative x squared, and then with transformations where it moves up a certain amount and all the good stuff. So if we look at our derivative, if we take a derivative of that one, for example, that should make our derivative to be negative 2x, which is linear. This is not a linear function here. So we automatically know here that if this is the original function, this cannot be the derivative. So that's gone. Okay, let's take a look at number 3 here. We know this part looks like the sine function, f of x equals sine, because remember sine goes through the origin 0, 0, and so here it looks like that. So here if we look at this function, well, first off, here we know for this function that kind of looks like it's like the cosine function going on there. So it goes through 0, 1, and then it goes down and back up. So it kind of looks like the derivative of being cosine. So if we look at it here, derivative of sine x is cosine x. So right here so far, that should be 1, and we have to just check number 1 and see if that is. And here, this hopefully you guys remember this function. This is your exponential function, which is like y equals e to the x or y equals a to the x power. We're going to talk about this more during this section, but looking at these parts here, if you take the derivative of e to the x, we're going to talk about it later on, like very quickly. We're going to talk about that it's actually the same thing as the original function. That's your derivative. So they're about the same. So here, we need to make sure we understand that these two things are pretty much going to be derivatives. So our answer here are going to be, it's going to be D. So here, this e to the x equals e to the x for a derivative. Sine x derived is cosine x. All right. So here are some rules that we have. So here, like I said already before, and this says it's the easiest rule of the year. It is going to be the easiest rule that you have because there's no work here. The constant rule is probably the next easiest one because it's just 0. But this one here, derivative of e to the x is e to the x. And again, that is e to the x right here is e to the x. So those are exponents there. So e to the x, the derivative is the exact same thing as the original function. Now, let's say now at this point that we do something else other than x right here in this spot. Let's say we put like a function there, or we put something, let's see if we can go bigger. There we go. Hopefully that's a little bit better. But let's say we have something else other than x right there. Let's say we have like x to the 1/2 power, or the square root of x, or sine x, or anything of that sort. Whenever you have something other than x right there, we're going to use this formula. We're going to do e to the u times the derivative of u. So e to the u du dx. Pretty much that's all it is whenever we start doing this. So with it, when we have something here other than x, we're going to do eu times the derivative of that u. So it's kind of like a chain rule kind of thing. It really kind of is chain rule all over again. This is why we learned that early on. All right, so let's take a look at example 2 here. And we're going to take a look at find the derivative of e to the 2x minus 1. So find d dx of e to the 2x minus 1 power. So again here, this portion here is your exponent. That's going to be your u. So I'm going to label this as u equals 2x minus 1. And so technically, as of right now, to match it with the formula that we have up top here, we're going to do e to the u, the ddx of e to the u. And again, that would be e to the u times u prime, or du dx. All right, so here, first off, let's do this part. So we have e to the u times u prime. We already know what e to u is going to be, but here, let's going to find our derivative for u, so we can substitute it in here. So here we find a derivative that gives you just the answer of 2. All right, so here we'll do e to the u times 2. And then this equals, substituting the u back in, e to the 2x minus 1. Oops, can't see it, sorry. Let's pull it back up. 2x minus 1, e to the 2x minus 1 times 2. And then the best thing to do is go ahead and move the 2 in front to make it simplified, to look better. Mathematicians, we like doing that part, Sorry, here we go. So that's our final answer here. So derivative of this function is 2e to the 2x minus 1 power. Sorry, that's my train of thought there. Okay, so that's that one. So let's go with 3. And this one we have, as you can see it there, that's e to the negative 3 over x. E to find the derivative of e to the negative 3 over x. So here again, we're going to write it like this. So d dx e to the u. But in this case, your u, again, would be negative 3 over x. So when we work this out, find our derivative, it's e to the u times u prime again, all over again. So again, we have to figure out what is e to the u. We already know what e to the u is, but we have to figure out what u prime is. So let's go ahead and work on that part. So we're going to, best thing to do, because you could do this as a quotient rule or anything of that sort, but I like using the power rule. So I'm going to move this up to have a negative exponent. So I'm going to make this u equals negative 3x to the negative 1 power. And then we're going to do our power rule. And again, because this is a coefficient in front, means we can move it away or move it in front and not deal with it until the end. So with the u prime, this will be negative 3. And then we take the derivative of the x to negative 1, bring the negative 1 down, subtract 1 from it, so it gives you negative 2. And so simplifying everything down with the radical, with the fraction, this will end up giving us 3 over x squared. Again, to bring it down, it makes it a positive exponent, and then negative times negative is a positive. So here we get e to the 2x, sorry, my fault. E to the negative 3 over x times 3 over x squared. And again, according to the like I said, like it's been said before, according to the AP test, you actually can leave it like that when it comes to like your free response questions, just in case you simplified it down incorrectly. But if you want to simplify it down completely, you would get this answer over x squared e to the 3 over x. So that way the negative exponent comes down and makes it positive. So these are our answers here. Okay, that separates the two. All right, so that is examples 1, 2, and 3 and the beginning of our exponential and logarithmic function